Now we head into section B, which is arguably more onerous, certainly much longer questions that you'll be answering in a separate answer booklet. So question 8, we have f of x is equal to x to the 4 minus 54x squared plus 60x, and you're given a domain. That's helpful. You should be thinking there, that's the window of my GDC. And they even draw the graph for you, so you can make sure it looks the same on your GDC. It tells you there are x-intercepts at x is 0 and x is p. They're labelled on the graph for you. There's a maximum at x is a, also labelled for you, and a point of inflection where x is equal to b. So lots of information there. The first thing you're asked to do is find the value of p. Now this whole question really is just, do you understand what graphs are, and can you use your GDC accurately? And if the answer is no, you really need to fix that. So I go into my menu, I'm going to draw a graph, so I go into 5, I clear whatever graph I had before, and I type in the equation of this graph, x to the 4 minus 54x squared plus 60x. I'm going to draw that, and then I'm going to remember that my domain here is between -1 and 6, so I go to my window. It's told me to go between -1 and 6. Let's see what that gives me. It doesn't really help, presumably because my y values are very different. So let's make my y values, -50 and 50, and see what happens. And I'm beginning to get the shape I have, but I want to go further down into my negative y-axis. So let's try instead -250 and see what happens. I'm still not quite far down enough, so I'm going to go to -500. Draw my graph again, and there you go. I have a graph that looks very similar to the one in my picture. So to find the value of p first of all then, I need to find the values where y is equal to 0, in other words, my roots. So I go on gsolve root, it will do this for me. And so I've got x is 0, y is 0, I'm already given that value. The value of p, I go to the right by 1. And so I have the value of p is x is equal to 1.14 to 3SF. And I'm just, for my own peace of mind, going to write 138434217, which is what I'm given, in case I need to use it in a subsequent part of the question. I'm asked to write down the coordinates of A. Write down means no working is necessary. Once again, I'm using gsolve. I want my maximum value, so I go to max, and it tells me my maximum value is at 0.562, 16.8. I don't really want the hassle of having to write those down to so many significant figures when they're so easy to find, so if I need them again I will use them. And then I'm asked to find the equation of the tangent to the graph of f at A. A number of ways to do this, but by far the easiest way is to think, well, at your maximum point your gradient must be 0. In other words, you just have a horizontal line, so your tangent will just trace out a horizontal line going through the value on your y-axis that you've already found for A. So that'd be y is equal to, and then 16.8. Alternatively, you could use y as mx plus c, m is 0, y is equal to c, and then substitute in your value at A, and that will still give you y is equal to 16.8. This is just a slightly more elegant solution. So that's part 2 done as well. Of course, you would be answering this in your answer booklet, but it's hard to fit one of those on the screen. And then asked to find the coordinates of B. Now, there are a number of ways to do this. I would approach this analytically. So I know that at a point of inflection, f double dash of x is equal to 0. So if I differentiate f of x, I get f dash x is equal to 4x cubed minus 108x plus 60. And if I differentiate that, I get 12x squared minus 108, which I can set equal to 0. So I get 12x squared is equal to 108. And therefore I have x squared is equal to 108 divided by 12, which is 9, and square root both sides. X is equal to plus or minus 3, but you can clearly see from the graph that x is greater than 0, so x is equal to 3. you're asked in the question to find the coordinates, so I then sub that back into my graph, which I can do using my GDC, gsolve, ycal, when x is equal to 3, y is equal to minus 225, and therefore my coordinates are 3 minus 225. Once again, you'll be doing this in your answer booklet. The advantage of this is that for part 2, find the rate of change of f at b. That's just f dash of 3. And so f dash of 3, go to my calculator. I found f dash x earlier, so f dash of 3 is just 4 times 3 cubed. 3 cubed minus 108 times 3 plus 60, which is minus 156. And that's my exact value. Part D, I'm then asked to let R be the region enclosed by the graph of f, the x-axis and the lines x is p and x is b. So that's between here and here. This is my region. And I'm rotating that region 360 degrees around the x-axis, finding the volume of the solid formed. In your formula book, you're told volume of revolution is equal to pi times the integral of y squared dx. And so in this case, I'm going to move my pi inside my integral because it makes the GDC easier to use. I've got pi times x to the 4 minus 54x squared plus 60x all squared, that's pi y squared, dx, and my limits are between p, which I found was 1.14, and b, which I found was 3. And then I simply just type that into my GDC. So I'm going to go into my graph mode. I don't want that equation anymore. Instead, I want this new horrible thing, pi times, and then x to the 4 minus 54x squared plus 60x all squared. I plot that graph, and it's pretty useless here because my V window is strange. I'm going to go zoom auto, see if that helps me a little bit. And it sort of has. It's helped enough for what I want to do. It doesn't matter that it doesn't look anything like the graph in the question because we are plotting, remember, pi times y squared. And now I want to calculate an integral. So I go gsolve along to integral. It asks you for your lower bound, which is 1.14. It asks you for your upper bound, which is 3. And it tells you your answer, which to 3SF is 80,900 units squared. So that's a 16-mark question that really is just, can you type things into a calculator accurately and do a bit of differentiation? If we look at the mark scheme for this, part A, you get 4 marks just for writing your final answer down. You're using your GDC. Part B, same thing, using your GDC, and it's said right down in the question. And B, part 2, you must give your answer as an equation because it asks for the equation of the tangent. But once again, final answer is fine. C, part 1, I use the analytical approach. F double dash of x is equal to 0. Solving, substituting your value in, finding your coordinates. Because then part 2 you could solve really easily. And then finally, part D, you're setting up your integral, 1 mark for that, and then you're evaluating using your GDC. So no point trying to do that analytically at all. Your GDC is your friend. 16 marks, sorted.